Good afternoon, students. So today we are going to continue with the Form 4 Physics, and today we are going to take a look at center of gravity and finding the center of gravity of an irregularly shaped piece of cardboard lamina. So it's called a lamina because it's flattened like a laminate. So that's what we're going to take a look at today. Now I'm actually going to do the experiment, the demonstration, so that you see what it is we're actually doing, and we are going to outline the steps as it relates to finding the center of gravity of an irregularly shaped piece of cardboard lamina. This is actually very often a common CSEC question where they ask you to describe the steps and sometimes draw a diagram outlining how this is done. Before we get to the actual procedure, we must of course recap what is the center of gravity. Now the center of gravity, if you remember, is often regarded as the point through which all the weight of an object seems to act. Of course, if all the weight is supported at that point, the object is said to be in equilibrium and will balance, right? Center of gravity, of course, alludes to the fact that the center of gravity is in fact in the center, and that is true for uniform objects like this meter rule here, that is uniform in dimensions, thickness, and so on throughout. So I can immediately balance it at the center at 50 centimeters because the center of gravity should be in the center for a uniform object. For a non-uniform object like this, however, the center of gravity is not always, of course, is not going to be in the center. And in life, most of the objects that we will come across will be non-uniform in terms of its dimensions. So today we're going to take a look at how we do that. Today I have a couple pieces of apparatus that you may be familiar or not familiar with, seeing that we haven't been to the lab just yet. And those pieces of apparatus, of course, will be this very important piece of apparatus here called the retort stand. As you can see, it's just a stand with a clamp, right, that we can use to fasten objects in the lab for our experiments. We are also going to be using other simple pieces of apparatus, just this little wooden block with a pin in it, and these two wooden chips are just used to help us to fasten this wooden block onto the retort stand. Another piece of apparatus that we're going to be using today is something called a plumb line. A plumb line is just simply a piece of line. This is in this case nylon attached to a nice solid piece of weight or mass, right? And it's of course can stretch the string basically taut, and or make the string taut for that matter, so that we can use it for our purpose. So I'm going to actually set up now so that you can take a look, and then we will outline the procedure as follows. So the first thing, of course, is to open the clamp in the retort stand. And as I said, these two metal chips rather, are just going to be used to be able to help us to fasten the actual pin together, right, to the, it's just a little bit stiff there, right, to the actual retort stand. This retort stand is, well, probably maybe older than I am, so it is working. It's a little bit creaky, but it will work, it will do the job. So the next thing we do is that we punch a couple holes into this irregularly placed shaped piece of cardboard. In this case I punched 4. You should ideally use at least 3 holes, so I of course put 4. So we must ensure that when we put this over the clamp here like this, and we were to allow it to swing freely, that it swings freely on its own. The next thing we do is that we attach the plumb line by making a little knot here onto the front of the retort stand here, right, and on the pin that we attach the cardboard lamina to. As you can see, we have to ensure that this plumb line isn't at any time touching the cardboard lamina. As you can see, the cardboard lamina seems to be shaking just a little bit on its own, and that's because we now have what we call a random error. That random error, of course, can happen at any time, and it's very often due to environmental factors. In this case, my air conditioning unit, the blower is actually causing this to move. So of course I have to find a way to mitigate against this error, so I'm going to switch off the AC. Right, so after switching off the AC and basically in this case preventing this from swinging as it shouldn't be, when the experiment is being conducted, the next thing we need to do is displace the plumb line and allow it to swing freely and come to rest. Alright, so when the plumb line does in fact come to rest, our job is to mark with 2 points where the plumb line comes to rest in front of the cardboard lamina. So I already took the liberty of marking 2 of the points, so we mark them like that and like that, right? And I will take it out now so that you can take a look. So if you were to look carefully, I marked 2 points here where the plumb line came to rest, and now I'm going to draw a line through it.